In this video, let's look at how Anthropic has built their multi-agent research system. Claude now has research capabilities that allow it to search across the web, Google Workspace, and any integrations to accomplish complex tasks. So in this particular blog post, they have explained what are the engineering challenges and lessons learned from building this research feature. Now, what is a multi-agent system? A multi-agent system consists of multiple agents, LLMs autonomously using tools in a loop working together. So research feature involves an agent that plans a research process based on user queries, then uses tools to create parallel agents that search for information simultaneously. Systems with multiple agents introduce new challenges in agent coordination, evaluation, and reliability. So this is how their architecture looks like. So this is the high-level architecture of advanced research. So here, if you see, there's a user asking a query in Claude AI, right? So here it is about what are all the companies in the United States working on AI agents in 2025. Make a list of at least 100 for each company, include the name, website, product description, what they do, types of agents they build, and their vertical industry. So this user request goes to a lead agent, which is an orchestrator. So their multi-agent research system follows an orchestrator plus worker architecture. So you have this lead agent, which is the orchestrator, which has access to tools like search tools, MCP tools, memory, run sub-agent, complete tasks. What this does is that based on the user request, it creates a plan and then it calls various sub-agents in parallel, right? These sub-agents have access to search tool. So they do the analysis and give it back to the lead agent or the orchestrator. Now, since the context cannot exceed 200K, it also has memory where it stores, the context. There is also a citations sub-agent, which then gives out the citations. So this is how the workflow looks like, okay? The system process diagram. So you have the user over here who's sending the user query to the system, right? The system creates the lead researcher. The lead researcher thinks, basically it plans an approach, then it saves the plan, then it retrieves the context from memory, right? It saves the plan into memory, and then it creates sub-agent for aspect A. Sub-agent is created over here, sub-agent 1, it creates it. It creates another sub-agent for aspect B. These run in parallel. So this particular sub-agent does web search, it evaluates, okay? And then it kind of completes the task over here. The other sub-agent 2 evaluates, does web search and completes the task too. Then the lead researcher looks into the results and it sees if more research is needed. If needed, it continues the loops. Otherwise, it exits the loop. Once it exits the loop, the lead researcher, then what it does is that it then processes the documents. It sends the result to the system. The system then processes documents plus it sends it to the citation agent, which processes the documents plus research report to identify locations for citations. It returns the citations, and this result is what is sent by the system to the user, right? It is also persisted in the memory. So this is the architecture, multi-agent system architecture of research feature in Claude.ai. Okay, here they have shown 2 agents. This could be 2 agents. This could be 15 agents, 100 agents, right? So this is their interesting architecture. So that's what they've explained over here of this is high-level architecture of your research, advanced research. What they're saying is traditional approaches using RAG use static retrieval. They fetch some set of chunks that are most similar to an input query and use these chunks to generate a response. This architecture uses a multi-step search that dynamically finds relevant information, adapts to new finding, and analyzes results to formulate high-quality answer. Okay, then they explain the multi-agent system process diagram, which is what I have covered. All right. Now, what is the advantage of using multi-agent architecture over here? So that's what they have explained over here. So research work involves open-ended problems where it is very difficult to predict the required steps in advance. You can't hardcore a fixed path for exploring complex topics as the process is dynamic and path dependent. So when people conduct research, they tend to continuously update their approach based on discoveries following leads that emerge during investigation. So this unpredictability in research makes AI agents particularly well suited for research tasks. So research demands the flexibility to pivot or explore tangential connections as the investigation unfolds. So the model must be able to operate autonomously for many turns, making decisions about which directions to pursue based on intermediate findings. So you cannot have a linear one-shot pipeline or a workflow for these kind of tasks, right? So what they are saying over here is that the essence of search is compression, distilling insights from a vast corpus. So sub-agents facilitate compression by operating in parallel with their own context windows, exploring different aspects of a question simultaneously before condensing the most important tokens for the lead research agent. So each sub-agent also provides separation of concerns. Each sub-agent can have its distinct tools, prompts, and exploration strategies, which reduces path dependency and enables thorough independent investigation. So this is how a multi-agent architecture helps in research over here, right? So once intelligence reaches a certain threshold, multi-agent system becomes vital to scale performance. That is what they're saying over here, all right? So even generally intelligence agents can face limits when operating as individuals, but a group of agents can accomplish far more. So this is very interesting over here. What they say is that multi-agent research systems excel especially for breadth-first queries that involves pursuing multiple independent directions simultaneously. So they found that a multi-agent system with Claude Opus 4 as the lead agent and Claude Sonnet 4 as sub-agents outperformed single agent Claude Opus 4 by 90.2% on their internal research eval. So a combination of different LLMs as different agents. Okay, Opus 4 is your lead agent. All your sub-agents are Claude Sonnet 4. This gives very good performance than a single LLM as an agent. Okay, so what they're saying as an example over here is that when asked to identify all the board members of companies in the information and technology S&P 500, the multi-agent system found correct answers by decomposing it into tasks for sub-agents, while single-agent systems failed to find the answer with slow sequential searches. That is what they are saying. This is because multi-agent systems work mainly because they help spend enough tokens to solve the problem. So instead of having a single agent, when you have multiple agents, they spend more tokens. And right, what they're saying is that the token usage by itself explains 80% of the variance, with the number of tool calls and the model choice as two other explanatory factors. So if you have an architecture which distributes work across agents with separate context windows, then you have more capacity for parallel reasoning. So that is what they're saying over here. And what they're saying is that the latest Claude models act as large efficiency multipliers on token use, as upgrading to Sonnet 4 is a larger performance gain than doubling the token budget on Claude Sonnet 3.7. Okay, so these are all the positive points for multi-agents, but there are a downside, which is about, you have more parallel agents, you have more tokens which are burnt, right? So the cost will definitely increase. Agents typically use about 4x more tokens than chat interactions, and multi-agent systems use about 15x more tokens than chats. So if you want economic viability, then use multi-agent systems only for value of the task is high enough to pay for the increased performance. So what they're saying over here is that unless you have a real high value task, you don't really require a multi-agent system, because multi-agent systems are going to be really expensive. They would burn 15x more tokens than your typical chats. So depending upon the task, you might go for a simple workflow using an LLM. And if there is a high value complex task, then you can look at multi-agent systems. Okay. So most coding tasks involve fewer truly parallelizable tasks than research, and LLM agents are not yet great at coordinating and delegating to other agents in real time. So you may not require, say for coding tasks, you may not require multiple agents or multi-agent systems. Multi-agent systems excel at valuable tasks that involve heavy parallelization, information that exceeds single context windows, and interfering with numerous complex tools. Okay, so when you should go for multi-agent versus when you should go for single agent or workflows, right? So that is what they're saying over here. And multi-agent may not be good for domains that require agents to share the same context or involve many dependencies between agents. So that's also not a good fit for multi-agent systems. So multi-agent systems are a good fit where you can actually have parallelization of different tasks. There it is good. So if your workflow or if your business is some kind of where tasks can be parallelized, then multi-agent systems are good. But if you have dependency between these agents, then multi-agent systems are not good at. Okay. So here they have discussed some of the findings, right? What is really important for multi-agent systems, right? What they are saying is that early agents made errors like spawning 50 sub-agents for simple queries, scoring the web endlessly for non-existent sources, and distracting each other with excessive updates. So prompt engineering becomes really important. So effective prompting relies on developing accurate mental model of the agent, which can make the most impactful changes obvious. So you need effective prompts, right? And what they're saying is that they build simulations using their console with exact prompts and tools from their system, then watch it agents, and they immediately revealed failure modes, and based on that they started improving their prompts. The next thing is you have the orchestrator. You have to teach the orchestrator how to, delegate to sub-agents. So each sub-agent also needs a objective output format, guidance on the tools and sources to use, and clear task boundaries, right? That's what they're saying over here. So what they said is that we started by allowing the lead agent to give simple short instructions like research the semiconductor shortage, but found these instructions often were vague enough that sub-agents misinterpreted. So you have to teach, or you have to give the correct prompts to your orchestrator such that it gives very clear goals to its sub-agents. That is what they're saying over here, right? Then what they're saying is that scale effort to query complexity. Depending upon how complex this query is, you scale the number of agents. And how do you do that again? You explicitly specify things like, if it is simple fact-finding query, then just use one agent with 3 to 10 tool calls. If it is a direct comparison, you might need 2 to 4 sub-agents with 10 to 15 calls each. And complex research might use more than 10 sub-agents with clearly divided responsibilities. Put these as explicit guidelines in your lead agent. That is what they're saying over here. Again, prompt engineering. Again, what is a simple query? Define that. What is a simple query? What is a complex query? Things like that. That is what they're saying over here. Next thing is that tool design and selection are critical. So using the right tool is efficient. Often it is strictly necessary. So specify those things properly. For instance, an agent searching the web for context that only exists in Slack is doomed from the start. So with MCP servers that gives model to access to external problem, this problem compounds as agents encounter unseen tools with descriptions of widely varying quality. So what they are saying is that you have to specify what tools to use properly. So they gave agents explicit heuristics. For example, examine all available tools first, match tool usage to user intent, search the web for broad external exploration, or prefer specialized tools over generic ones. So if you have bad tool descriptions, then your agent can go across, completely wrong paths. So this is also important about what tools are available to your agent and how well the tool descriptions are and what these tools can do, right? You should have each tool needs a distinct purpose and a clear description. And then what they're saying is that let agents improve themselves. So what they're saying is that Claude 4 models can be excellent prompt engineers. When given a prompt and a failure mode, they're able to diagnose why the agent is failing and suggest improvements. So they created a tool testing agent. When given a flawed MCP tool, it attempts to use the tool and rewrites the tool description to avoid failures. So this is about how the agents can improve themselves, right? Then what they're saying is that search strategy should mirror expert human research. Explore the landscape before drilling into specifics. So this is how humans would do research, right? So you look at breadth-wise first, and then you start looking at depth-wise. You progressively narrow focus. Okay, that is what they're saying over here. And guide the thinking process. So they have extended thinking mode, which leads Claude to output additional tokens in a visible thinking process. So you can make use of that feature, right? So the lead agent uses thinking to plan its approach, assessing which tool fits. So by using extended thinking, it improved instruction following, reasoning, and efficiency. That is what they are saying. Okay, sub agents also plan and they use interleaved thinking after tool results to evaluate quality, identify gaps, and redefine their next query. So this is what they're saying over here. Parallel tool calling transforms speed and performance. So complex research tasks naturally involve exploring many sources. So early agents executed sequential searches, which was painfully slow. That is where they introduced two kinds of parallelization. The lead agent spins up to 3-5 sub-agents in parallel rather than serially. The sub-agents uses 3+ tools in parallel. So using this, it cut research time up to 90% for complex queries, allowing research to do more work in minutes instead of hours. So this is also important over here. So this is an excellent article about engineering multi-agent research systems. Please read this article too if you are working in the space of multi-agent, multi-agent system using LLMs, right, for solving your business problem. They have other things about how do you effectively evaluate agents. Okay, so what they are seeing is that traditional evaluations often assume that AI follows the same steps each time. Given input X, the system should follow path Y to produce output, but multi-agent systems may not work in this way. Even with identical starting points, because of uncertainty in the way agents are called, you would have different paths to your final answer. Okay, so instead what we need is flexible evaluation methods. So start evaluating immediately with small samples. In early agent development, changes tends to have dramatic impacts because there is abundant low-hanging fruit. A prompt tweak might boost success ranges from 30 to 80%. So you can spot changes with a few test cases itself initially. So they started about 20 queries representing real usage patterns, and then they started iteratively improving the system. LLM as judge evaluation scales when done well. So you can use LLMs as judges to evaluate. Okay, that is what they're saying over here. They used an LLM judge that evaluated each output against a criteria in a rubric like factual accuracy, citation accuracy, source quality. So they experimented with multiple judges to evaluate each component, but found that a single LLM call with a simple prompt outputting scores from 0 to 0.0 to 1.0 and a pass-fail grade was the most consistent, aligned with human judgment. So that is what they're saying over here, right? you also need human evaluation. That is what they are saying. Human testers notice that early agents consistently choose SEO optimized content forms over authoritative but less highly ranked sources. Adding source quality heuristics to prompts help resolve this issue. So you still require human evaluation to improve the system. That is what they are saying over here, right? Then you have production reliability and engineering challenges as with any traditional software. Okay, so that is what they are talking about over here. So agents can run for long periods of time maintaining state across many tool calls. This means you need to durably execute code and handle errors along the way. So this is what they talk about over here. Then they talk about debugging benefits from new approaches. So agents make decisions and are non-deterministic between runs. This makes debugging harder. Okay, so adding full production tracing helps them diagnose why agents failed and fixed issues systematically. Beyond standard observability, we monitor agent decision patterns and interaction structures, all without monitoring the contents. So high level observability helps us diagnose root causes, discover unexpected behavior, and fix common failures. Then they talk about deployment, which needs careful coordination. So because agent systems are highly stateful web of prompts, tools, and execution logic that runs continuously, they need to deploy agents. Updates agents might be anywhere in their process, so you need to carefully do the deployments. Okay, synchronous execution creates bottlenecks. So lead agents, sub-agents, lead agents execute sub-agents synchronously, waiting for each set of sub-agents to complete before proceeding. So this simplifies coordination, but it can create bottlenecks. So asynchronous execution would enable additional parallelism, but you need to handle it properly. That is what they are saying over here. So this is about multi-agent systems and how they have proven valuable for open-ended research tasks. Excellent article. You can check this out. Here they have kind of queries which user typically ask for agents for deep research, and what they are saying is that the top use case categories are developing software system across specialized domains, develop and optimize professional and technical content, 8%, develop business growth and revenue generation strategies. So these are some clustered plot showing what categories people typically ask the research feature for. Analyzing financial markets. It talks about research in brain science, psychology, and substance effects and things like that. So please check out this article if you are working in multi-agent systems for features like research or for any other features. A lot to learn from this particular article or blog from Anthropic. So this is a very good resource if you want to learn more about multi-agent research systems. Hope this video is useful. See you in another video.